I will give a short, brief talk. Welcome. It's my pleasure to introduce Dr. Korhan Erturaç. He's from Turkey. He's from the Institute of Earth and Marine Science at Gebze Technical University. He did his bachelor's in geological engineering in Ankara University, and then after that, master's and PhD at Istanbul Technical University. He's specialized in active tectonics and quaternary stratigraphy along the North Anatolian Fault. His postdoctoral research is mainly on Anatolian obsidian sources at the Institute of Frances Etudes Anatolians and Luminescence Dating at Baylor University in the United States. Since 2016, Dr. Erturaç led numerous national and international projects, investigate Earth surface processes across Turkey, Balkans, Magnolia, and Antarctica. He also remains actively involved in the Neolithical excavations research in Western Anatolia. And today he's going to present one of our collaboration work, is the Geochronology of Coastal Record to understand transgression and regression episodes of Black Sea for over 125 Ka. And please, floor is yours. Thank you.
Thank you. Thank you very much. Okay. It's a pleasure to be here and discuss the outcomes of our project. It's been, I think we have started 4 years ago. And now the project has ended literally in a week ago. And last week, we presented the results in European Geosciences Union annual meeting. So it's a little bit difficult because we have lots of data concerning the study, and I try to manage everything to get together to understand what's going on in the Black Sea. So, to be brief, but I won't be brief, I'm sorry. So this is the northernmost part of Anatolia. This is Sinop Peninsula. And it's very interesting because this is the second place of the nuclear power plant of Turkey, selected for nuclear power plant. And as you can see, we have a very nice section which we detail. And there will be a last slide about this section as well. We were there, and we have some preliminary results. And it's the best, maybe, part of Turkey, Sinop Peninsula. It's a nice place to visit. So we are a large group of geologists and geochronologists, and working with Bulgarian Academy of Sciences Geology Department. It's a bilateral TÜBİTAK Bulgarian Academy of Sciences project. So we are collaborating with Altu and Fernando as well. For geochronology, our main method is luminescence, and we are collaborating with Eren Şahiner from Ankara University. And also we have a partner who is an expert on paleontology, especially mollusk paleontology for the Pleistocene. And the idea is to understand the sea level changes of the Black Sea during the last glacial period. So most of you know, but I will make some introduction and get to the point. This is LGM world, and what does it mean? That we are in the maximum, last glacial maximum period, which is the northern hemisphere is highly covered with ice sheets, and the southern hemisphere as well. So the sea level accordingly dropped more than 100 meters in the open seas. So this is the LGM world, and the sea level, you can see the sea level, 120 meters in here, tropics, 130 meters here, 150 meters. But what we are concentrating on the semi-closed basins, which is the Black Sea here and the Caspian Sea. So what is the state of the art? What happened during the glacial period of Earth? What happens to the sea level? Everything started with, but the first very detailed study about what happened during the transition between the last glacial maximum to Holocene is by Fairbanks in 1979. And what he did was to sample coral reefs 125 meters below sea level and dated them. And also at the same time, he made oxygen isotope analysis. So we knew that the sea level was low, 120 meters, and then increased very fast in 10,000 years to today's level. This helped us to, maybe recalculate or estimate the past sea level by using the deep sea drilling program. So with that, Chappell and Shackleton in 1987, which are used by Prezzoli in 1993, used the estimated sea level curve based on the oxygen isotopes. So this is recent, and 160,000 years, you can see that during marine isotope stage, the sea level was below 120 meters. And then during the Eemian period, which is the last interglacial, and then make different areas. So you can see that the resolution at that time of the past sea level was very low. And in time, they increased with the age models and increased in the isotope geochemistry, the detail of the isotope chemistry. We had a better, it's not very good seen here, but we have a better resolution. For example, this is published by Sidal et al. In 2003, and from Red Sea cores by using the benthic isotope records. So we have a very high detailed sea level curve for the last glacial. And this is published by Spret and Lisiecki in 2006. This is also based on a stack core data, and they use it to understand the sea level change during the glacial periods. So in time, we have a lot of different curves. As you can see, this is the last 150 years, and we have low stands and high stands. And during the stadial periods, you have, let's say, lower stands, and interstadial periods during the Ice Age, you have high stands here. But as you can see, there are some differences between different parts of the world. So there is no directly, unified curve of sea level during the last glacial. So today's discussion is mostly about, I try to summarize it here. So you can see we have other curves, but some of them are very low. For example, in 45,000 years, this is isotope stage 3. And the recent studies suggest that the sea level was a little bit higher than proposed before, like during the interstadials, like this. So this is the state of the art of the sea level curves, and also what has been discussed now by the last interglacial Eemian period, and what we know that the sea level was a little bit higher than today. So this is also another focus study. People are, concentrating more and more on isotope stage 5 to understand what will happen to the Earth in the future. Oh, sorry. Okay, this is our study area. Actually, it's well, the colors are not good, but hopefully you can understand. So this is the Black Sea. We will get detail. This is the Caspian Sea, and there are inner seas which are now connected to the Mediterranean and to the Atlantic Ocean, to the open seas. Caspian Sea is now isolated, so there is no connection. It's an isolated lake. And what we know that during the glacial times, for example, LGM, the sea level was 125 meters lower than today. So you see that all these yellow to greenish and red parts were exposed shelf areas. So white flats were open land area. And where is the drainage to white, or where is the water source of the Black Sea? It is via Bosphorus Strait to Marmara Sea, then to Dardanelles Sea, to the Aegean. Okay, this is one source. And the other source is the drainage network. For example, the Black Sea is being fed by big rivers like Dnieper, Don, Dniester, Danube, so which are draining a large area in the Siberian or Ukrainian steppes. And the Caspian Sea is also fed by rivers from east and from north with Volga River. So their drainage divide is this gray scale area. So to get a little bit more closer, this is the Black Sea. And this is the wind roses, actually. So you can see that the wind is flowing to the east part, flowing from northwest to southeast, which is reflected in the dune records as well. And at the west is from north-northeast to the southwest. So these stars are our study areas. We are detailing the coastal record. And these polygons show the previous studies, old studies, age constraints on the Black Sea level. Again, I will emphasize this. This is Manic Strait. It's not visible here, but this is Caspian, and this is the Manic Strait. And during the high stands of the Caspian Sea, we know that there is a connection between Black Sea and the Caspian, and it's also been discussed recently in the literature. So we are connected to the Marmara Sea, to Bosphorus, and the Dardanelles, which is important here. The Bosphorus Strait has a sill depth of 35 meters. So if the global level falls down 35 meters, you have an isolated sea, the Black Sea. Sometimes in the history, we know that it's a freshwater lake, or sometimes it's brackish. And it's important also to mention that not in the Turkish part, but in the northwest part, in the Danube Delta area, you have a wide flat of shelf area with the delta area. So very big place here. So this, why Black Sea? It's maybe you know this. It was very popular. Actually, it was when I started my graduate degrees in Istanbul Technical University. The book was recently published, and it was very popular at that time. So when the Istanbul Technical University started sea programs, and it was just after the Istanbul earthquake, let's say, and then people are working more and more in the marine geology. So these guys, William Ryan and Walter Pittman, write a book. And before that, they published a paper in 1997 claiming that 9,000 years ago, there was a catastrophic flood in the Black Sea that in a 1 year or 2 years covered the whole shelf area. And this event remained in the people's mind as the Noah's flood. This nice book is a very perfect, very so-called perfect, let's say, hypothesis. And after that, after the 25 years they first published it, there are lots of numerous studies discussing about if it was gradual flow, or it was from Black Sea to Marmara Sea, or it was an upward flow. And so the last, there are still papers going on, but there was a joint book about, Valentina Janko-Hombach and others, Palin, and published a book in 2006, which collaborated special issues, like of special issues, collected many papers. I think this is a 500 pages book. So it still discuss about what happened during the LGM to Holocene transition in the Black Sea. One of the papers is by Yanchelina et al. In 2017, and what she did was to recalibrate all the ages and provide new data, and with isotope measurements as well, and C14 ages. She claimed that in about 9,000 years ago, there was an abrupt increase in the sea level, advocating the flood hypothesis. So we are not quite dealing with this time period, actually. We are looking a little bit older. So what happens, we know about the global sea level curve. What do we know about the Black Sea level curve? It's interesting because our first knowledge is coming from Fedorov in 1979. These are Soviet-era scientists. Fedorov has provided a very interesting and very nice sea level curve for that time, about the same time with Fairbanks, a very nice curve for the Holocene of the Black Sea. And then Andrei Chapaliga in 1984 published a sea level curve for the late Pleistocene, hypothesizing some high stands during the LGM, during the glacial period, which they called Karangat transgression and Srozin transgression. And between that, you have very distinct low stands. And this one, for example, a freshwater lake of the Black Sea. If we put this data together and start to make a kind of calibration, This is what they used in the time, for example, Chapeliga, ages of Chapeliga in 1984. And Trikonov et al. In 2019 published some uranium thorium ages. But these are very old Soviet time uranium thorium ages. So we don't have how do they measure, they're just giving you numbers, and we don't have the stratigraphic control. What's the position of the samples? So what we have is just the data, the numbers, but we can assume that these are the high stands. So this is what we know until our project. These are some ages and a sea level curve. This is for the Black Sea, and this is it's not very visible, but this is recently just published by Tudorin. She gathered all the data from the Caspian Sea and proposed some low stands for the Caspian, Atelian 1, Atelian 2, and Huelian 1 and Huelian 2, also Hercynian transgressions. What's important here? So you have this is the sea level curve. This is starts from modern sea level, and this is let's say minus 20 meters is the today's level of the Caspian, and this is plus 25 meters is the sill depth of the Manikerch Strait. So if you increase the volume of Caspian Sea, you have a transgression going directly to the Black Sea. So there is a faunal exchange. That's the idea. So if you compare these curves with the global sea level curve estimations, we have a very lacking resolution. This is the idea. We don't even know after 25 years what happened at the Black Sea. So state of the art, what has been discussed about these connections. For example, Wout Griezmann in 2019 has published a ESR review paper about these connections and the co-evaluation of Ponto-Caspian Basin. And they propose sea level curves. This is also from literature, and some transgressional periods for the, let's say, middle late Pleistocene. This is very old. And this is from Yanina, and in 2014, 2020. Interesting is that all these papers repeat the same thing, that you have some connections in the past, something happened in it, but get new data and publish the same thing. Nothing is close to a sea level curve or on details. So this is Tudorin et al. 2022, and this where she, I think, gathered about more than 100 ages in the Caspian and made a sea level curve for the last, let's say, 50,000 years. So everybody is sleepy now, or my? Okay, what is our goal and what are the outcomes of our study? The goal is to map the coastal deposits. It's very basic. It's a very fancy environment. It's very nice. You just walk on the sand and you see some dunes and you see some coastal deposits and also it's a nice place to study in the Black Sea coast. But mapping them is going to be a little bit difficult because you have to find exactly what you're looking for. And we just studied the exposed outcrops, and we were lucky to have a lot of exposed outcrops. So, and the extent of our study area is very large. It's about 1,000 kilometers, something like that. So to map the deposits, and to identify the evolution of the deposition environment. What kind of deposition environment it is? Is it a coastal deposit? It's a beach deposit, it's a dune deposit, or it's something else? And then deploy a detailed geochronology to understand the timing of the deposition. So we used luminescence, basically, and quartz luminescence at the OSL. And if we have mollusks, if you're in the good time range, we use C14. And now we are using uranium thorium to calibrate all these ages together. It's a very challenging subject because luminescence can be misleading. Uranium thorium has some problems with the open system. C14 has also its own problems. So we are looking for to match, if any degree, to get a nice chronology and nice geological constraints. So to reconstruct the late Pleistocene sea level curve, if you're lucky. And at the same time, if you find the mollusk, you can make some isotope analysis, see, for example, carbon or oxygen, or now strontium isotope analysis, which can help you to track the source of the water which the mollusk makes its shells from. So you can differentiate if it's a freshwater lake or if it's coming from the Caspian or even the North Sea. So it's interesting, or it's Mediterranean. And at the end, understand the dynamics of the Mediterranean, Black Sea, and Caspian connections, if you're lucky. And provide geological and geochronological constraint to revise ice sheet models during the LGM. Because ice sheet models, the changes in the ice sheet, they are modeling it now, it's very popular. It's based on the isotope data from the sea level data. So they're making modeling based on geological data. But now we are trying to provide them more data, more geological constraints to help them build better models. And if we are lucky, again, we try to understand Holocene climate changes, Aeolian storm periods, or sea level changes. And also, as a Turkish geologist, we are looking at the tectonic contribution. So this is, the east panel shows, it's a nice review in ESR by rover in 2016 about how you can map and use the coastal record to reconstruct the sea level. And it's basically used for the Aegean stage in the last interglacial. And here we have some examples from the coast. This is very close to Istanbul, Şile. And this is İrem. İrem is right here. And as you see, you can see a contact of sediments. It's not very visible, but there's a small, very small sandy layer just here, which is inclined towards the sea. And on the top, it's covered by Aeolian deposits because they are inclined very steeply towards the land. This is dune deposit. So what we do is to take a sample from here for luminescence and take a sample from here again for dating, and then measure the position and relate it with the sea level. This is what we do. It's very basic. So what we know now, it's interesting. This is the last outcrop we found in the Black Sea. This is Aegean stage. It's a half meter of the last interglacial sea level of the Black Sea. And this is about 120,000 years old. And this is 100,000 years old, this dune. So you first start with the beach deposit, and then when the sea level dropped, there was dune formation and covering all this. And there's another one, which is a little bit thicker here. And you see, again, the beach deposit inclined towards the sea, and the dune deposits inclined towards the land. So we sample and date. And this is about 100,000 years old, and this is about 50,000 years old. You see, again, this is a very nice outcrop, which a lot of mollusks. So we have inclined to the sea, and on the top it's covered with dune deposits. This is from Sinop. You see these are parallel-looking bedding, but they are inclined to the sea, and you can see this covered by dune. This is 70,000 years old. This is about 55,000 years old. And here it's more difficult to see, but we have a fluvial delta east of Sinop. You see this is a terrace covered with slope deposit. You cannot see it, but you can see the sea level here. This is better, I think. This is the sea level, and this is the terrace. And here is a nice position that we dated both with OSL, 2 ages, uranium, thorium, and C14, and everything fits perfectly. It's very nice for us. And this is the second step. Here you can see it's about 35 meters above sea level. And we dated with uranium, thorium, not with C14 this time. And I think 4 OSL, which again is a good match. And this is the last one, about 55 meters, 60 meters above the sea level. And this was, we didn't have any fossil fauna, so we used OSL, just 2 ages. But it was a nice place to study. So this is the another aspect of our study. If we find an outcrop, it's a bleach deposit, or if you have mollusks, it's very good for us, because with the help of our colleague, a paleontologist, we can identify the mollusks, even bivalve or gastropoda, and we can identify the species and where they're coming from. Are they Caspian origin? For example, you can see there are some species which are called Didacna. Didacna is completely Caspian fauna. And some of the species are Mediterranean, some of the species are let's say, like a mixture, Black Sea and Mediterranean. For example, you have Austria here, as you can see, or you can see today's living mollusks as well. Mytilus, for example, is very common. And this means that you have today's salinity or higher salinity. At the same time, you can make isotope analysis with this data. We just started, but we will do more and more. So, at the end, coming close, we have chronology. I won't bore you with the details of the dating and the results, stuff like that. What I did is to make probability density functions to understand the timing of the deposition, timing constraints of the deposition. This is for late Pleistocene beach deposits. So we have 3 high stands here. And this is, we have 21 ages, by the way, 3 C14, 2 uranium thorium, and 16 OSR. And this is for dunes. We have 11 ages. So you can see we have also 3 dune formation stages. And this is, interestingly, we didn't focus on Holocene, but we have 49 Holocene records, 38 for dunes, and 11 for fossil beach. We have uplifted or storm-destroyed beach deposits. We have dated with several methods like 4C14, 2 uranium thorium, and 5 OSR. All these facts fit perfectly. So when we combine them together, we constructed, we tried to construct a past sea level curve. So this is the last interglacial, so the sea level was today or about today's level, we don't know yet. I think we know about 1 meter above today's sea level. And then we have a drop when the glacial time came, and there was dune deposition at the coast. And then there's a high stand again here. So in between we have a hiatus, we don't have deposition. Maybe we do, but we haven't dated them. So we have a high stand, and then we have a sea level drop, and this is a distinct hiatus. So the hiatus periods indicate that the sea level was below 50 meters, I think, because exposing the whole shelf area. That's the main hypothesis. And then we have another high stand, which is lower than today's level. This was possible by, measuring the position of this, in different parts of the Black Sea. Some of them are uplifting, some of them are not. So we could combine all this data together to understand the exact position of the sea level. So we have a lot of ages, and we can say that this is also high stand. And at the same time, with the mollusk fauna, we can say that it all started with Caspian intrusion, then maybe continued with the Mediterranean connection. So we have a Caspian connection at that time. And then we have another hiatuses, and then dune formation, and then hiatuses, and dune formation, very distinct, very lot of ages. So we have a low stand and, a transgression again during isotope stage 3, and these high stands took about 10 to 15,000 years. This is very interesting because if you correlate it with the global sea level, it's completely acting by its own. So it's also very interesting. And when the LGM came, your sea level dropped distinctly, and then maybe rised, and then dropped again, and maybe with the flooding or not, I don't know, increased again. So when you put all the data together, from the literature and our studies, we had started from here. These were the previously published ages, and with calibration for C14, because this is not, I think this is a conventional C14 dating because it was before AMS time, so there was no calibration at that time as well. So when you calibrate it, you can see that they doesn't quite fit this curve. But it's okay, no problem. And we have the Caspian sea level curve as well. And we have in the literature, we have some ideas about the past connections. For example, from Sofular Cave, Bedarchar et al. In 2011, proposed by his isotope data, proposed some connection between the Caspian and the Mediterranean or the freshwater Black Sea. This is like it. And some studies, like Krinsman Wout, has compiled data together from the mollusks and proposed some connections. The green ones are the Caspian connections, and these guys are Mediterranean connections. And this is from strontium isotope ratios for the connections, past connections. So they don't really overlap the timing and the connection. So this was our data. And so we propose for now that we have one Caspian influsion, not during the isotope stage 3, but isotope stage 5A. And these are the strontium data, published data here. You can see there is a line, and above this line, this is Mediterranean, we are sure of that. And below that, you have freshwater Black Sea, and you can have the Caspian intrusion here. So these purple ones are our preliminary results. They are a little bit confused, so we have to make more and more analysis. It was a test, and now we will try more. And also, this is our sea level curve and ages, and global sea level reconstructions, and you can see that our high stands quite fit the recent published global sea level curves. But they never reach beyond the Bosphorus sill depth. What happens? So what we suppose that there's a transgression in the Black Sea, and then pouring to the Marmara, and then stops there. This is the idea. And it's also very complicated. By hydrologically, we have to test this hydrologically. So where the water is coming from, this is also, it's not very seen visibly, but please follow the red line curve here. This is a proposed ice sheet volume area during the late Pleistocene. So it starts with a glaciation here, then the glaciers melt, your sea level rises, and then again glaciation, your sea level drops, and then it melts, you have also a high stand. So you can see this is published by Evan Govan and Bachelor very recently, and this is Fenno-Scandinavian ice sheet modeling by Manger in 2023. You see that they have some problems with the chronology. So we are in touch with these guys and to help them modeling. So in series of time, in 10,000 time scales, I'm going to show you what happened in the area, northwest. How? So this is 110,000 years ago. I didn't have time to make the sea level changes visible. Also, this is a MotNet map. It's a nice map. But I used it on my, it's not a digital map now. So, okay, here we are, about 110,000 years. Please see the red line. And you have a very distinct glacier advance. Here is the glacier. It's not again seen here very good, but probably with the YouTube recording it will be better. So you have a low stand globally, and also in the Black Sea as well, and also the Caspian Sea. And when you move further in time, you see that they shrink a little bit year to year, and you have a high stand in the Black Sea and all global seas. And during the isotope stage 5C, you have another glaciation, advancement of the glacier like this, and then you have a low stand. And this now governs modeling. This is 3D volumetric model. You see there's a very low glaciers are here, and this area is not glaciated. And now you have a high stand, about 80,000 years ago. And then glacial advance. And this time we have contours here, so try to be detailed. These are 500 meters, so the thickness of the glacier is about 2 kilometers here. So what you have is that you have a regression. And then in time, this is the isotope stage 4. This is the low stand. This is 1, 2, 3, 4, 5, about 3 kilometers of thickness, ice thickness. So what is important here, what to discuss, where is the water coming from to the transgressions? Here's a good example. This is the drainage divide of the Black Sea and Caspian combined. So what happens when you lower the glacials like this, you have a meltwater trapped here. And the threshold between this divide, within this divide is 100 meters. So if you raise the water 100 meters, what you do is by the rivers, you make a large amount of fresh water towards this area. Then you increase, and then you make the connections and increase the salinity as well. So this is the model. It's not proposed by me, it's proposed by other researchers, but they couldn't find good age constraints in this area, Siberian Peninsula. Because I think most of the sediments are buried. So do you need boreholes? We are lucky in Turkey that we have, uplift. So everything uplifts, so you can find the record very easily. It's the same problem with the Caspian. And as a large working group work in Caspian transgressions, they fail all the time because when they sample, maybe maybe you heard about it. This Dutch group is working on this and publishing a lot of papers. They sample something is 400,000 years old, and the next is 100,000 years old. So there is a kind of intermixture of the sediments. You cannot separate your sediments. So this is the hypothesis. So when the sea level, when the glacier ice sheet, retreats, you have water here drained to the Black Sea and the Caspian by Volga and Dnieper, and at the same time we have to consider about these alpine glaciers as well. The whole area was glaciated at that time as well. So, so you can see that during the isotope stage 3, we have very few glaciers in the area, and maybe in the northern Americas, I don't know, but here we don't. And this is the high stand. And this is the beginning of the regression, and this is the last glacial maximum. So all the sea level dropped to less than 100 meters. Okay. Yes. So this is the other outcome. By using this, let's say, coastal record, we can constrain the amount of uplift, annual uplift along the sea level, along the Black Sea coast. So here we have a 0.6 millimeter per year uplift east of Sinop Peninsula. This is Sinop, and it increases to 0.2, 0.15, 0.5 here, 0 here, 0 here, and in Bulgaria we have 0.282. And this is the section we wish to study. We studied, but we will continue detailing. It's interesting because it's 40 meters thickness, and we have some preliminary OSL ages. This is 200 years, 1,000 years. This is 140,000 years, and we have a distinct layer which has a lot of Austria, Mediterranean fauna, completely, and we have also ooid formation. Maybe you know ooid formations. Ooid is, it's formed in the very narrow, shallow coastal zone with high temperatures of water, and you have carbonate precipitation along the grains. For that, you need 25 to 30 degrees at least temperature of the sea, and it's never been published before for the Black Sea. Black Sea is about 10 to 15 degrees Celsius now. So during isotope stage 5E Ammian, we proposed that we found a very hot Black Sea. So that will be interesting by means of climate. This is the ooids, by the way. This is microscope, and this is scanning electron microscope. So what we're going to do is to make a comprehensive dating and isotope analysis, and to understand what happened during the isotope stage 7 here until most probably isotope stage 4. So it's a nice record of the sea level at the coastal area. The last, so this is the Holocene record. What we found with lots of ages, that we have Aeolian episodes. Here you can see. And between these Aeolian episodes, some of the record has been eroded abruptly, which indicates erosion due to a severe storm. So we have several storms. This is our suggestion. And this is a correlation between past storm records, proposed climate changes in the area, and with North Atlantic oscillation. For example, Sofular K precipitation data stuff like that. And with this, we proposed a new project in which Cenieh is also our contributor to NATO multi-year program to Science for Peace. We're waiting for the result. But to understand, to study detail the last 5,000 year frequency of the storms in the Black Sea area. The Black Sea is a very important water bodies because there is a war going on, there's a very high conflict, and lots of people are working there. And this is an example. This is close to Istanbul, coastal area. You can't see here, but these are large nails coming from a wooden ship, the Ottoman period. And so it's a shipwreck, which is been lithified in sand. And also we found is an amulet cliché, I think. This is written in Ottoman, and you have a cliché, and then it's like a prayer. It's the guy who has it just puts it on the paper, and you just carry it with your neck. So this is what we found. So there was a guy in the ship who I hope didn't die. So we have also shipwrecks as well. So it's also interesting. We will see if NATO accepts this program. So this is the end. Thank you very much.
Thanks a lot, Korhan. It's very interesting. So, any questions? Any part that would like to have a comment?
Sure.
Thank you. This was really interesting. It's outside my research area, so I'm going to ask kind of a question from over here. When you were talking about the water, that at some points the water goes between the Caspian, the Black Sea, and the Mediterranean, have people done much work yet looking at vertebrates? So was the water going both ways at that point? And so is there much evidence of like fish and other vertebrates going back and forth?
Yeah, that's what happened, I think. But by the way, it's a very difficult question. But we know that we have now today's, waterways. For example, we know that the Mehmet Strait is 25 meters above sea level, and the Bosphorus Strait is 35 meters below the sea level. So the idea is that you have to increase some water, and then you just directly pour it to the other side, other basin. For that, in 50,000 years ago, let's say, or 60,000 years ago, these straits, their depth and elevation should be the same. This is the idea. We don't know what happened in the time period. But we know that as a geologist, that this is what geologists do. We have proof, evidence, that these connections should have made. This evidence comes from the position of the terrace and also the fauna. Today, we have very few Caspian fauna in the Black Sea. We know what they are. They're common because the salinity tolerance of the mollusks, let's say. And if the salinity increases, for example, they die, and a new fauna adapts. It can be very fast, I think, in several thousand years. So we have the proofs, so we have to track the sources, and we have to model the connections in time. Because it's not easy, because there's a whole very hungry, low-level global sea level. And you are relatively a small basin, have a lot of water, and you pour it to the Black Sea. So there must be a continuous chain of transfer, I think. So it's also very interesting.
Yeah, it really is. Yeah, thanks.
Anybody else? Just one more thing is, do you have any data that combined with cave deposits and are there any caves that along your study area?
In the coastal zone, you mean?
Yes.
There are caves, but nobody studied them.
Nobody studied them. Might be a good idea just to check with the speleothem data in terms of...
When the sea level rises, you stop forming speleothems. Mm-hmm. It can be interesting. Yeah. We have that in mind, but it's difficult. Okay. We need funding. Thank you. If the NATO is accepted, we can dive, also.
Okay, then thanks a lot just to give this talk. And I haven't met Korhan before Cenieh, so Cenieh actually opened this opportunity, and Cenieh Korhan approached me that can we try the uranium thorium dating here. So that's how we met, and we continue now with, there is a NATO project we actually submitted. Hopefully we will hear good news soon. And another project is going on Antarctica. He didn't mention about that.
Yes.
We just also, there was a well-preserved portion of a whale we just dated, and it also fit with carbon dating. So we keep doing, because it's very good, this type of study for us, for our lab, just to check. He already had some data, strontium data and carbon data, so we tested ourselves in almost along the 2 years, and it looks working pretty well. And thanks for your collaboration as well.
Thank you all too for your